Time for some e-learning with Miss Atkin. E-learning with Miss Atkin. E-learning with the puppy. E-learning with Miss Atkin. Yeah. Alright, scholars, today we're going to talk about section 3.4, proving lines are parallel. But first, I'm going to do a little recap of what we talked about in the last video. Recap. So last time we talked about if you have parallel lines, then a bunch of things are true. So we said if the lines cut by a transversal are parallel, as indicated by those arrows, then the corresponding angles are congruent. That was one. We also said if the lines cut by a transversal are parallel, then the alternate exterior angles are congruent. Alternate exterior angles are congruent. That was number 2. We also said if the lines cut by a transversal are parallel, then the alternate interior angles are congruent. That was number 3. And finally, the last one, if the lines cut by a transversal are parallel, then the same side interior angles are supplementary, meaning they add to 180. Same side interior angles are supplementary. I wrote these numbers way too tiny, but that's angle 1, that's angle 2. They're on the same side of the transversal, and they are interior to the parallel lines, hence the name same side interior, and those angles are supplementary. All right, in all these pictures, I tried to draw the parallel lines differently to kind of get your brain to work around all these different orientations. Anyway, that's what we talked about last time. Today, we're going to talk about the converse of all of these theorems, meaning we're going to take our if and then and flip them. So we'll say if the corresponding angles are congruent, then those lines are parallel. If the alternate exterior angles are congruent, then those lines are parallel. If the alternate interior angles are congruent, then those lines are parallel. Or if those same side interior angles are supplementary, then the lines are parallel. Those will be all of the converse theorems to these guys up here. Cool, let's get to it. So the first one is the corresponding angles converse. That says if two lines, like M and N, are cut by a transversal T such that the corresponding angles are congruent, like these blue angles are congruent, then we know the lines are parallel. Then M and N are parallel. We can put our little parallel markers. Okay, so if any pair of corresponding angles are congruent, then we know the lines are parallel. That's the corresponding angles converse. Here's our next one. The alternate exterior angles converse. If two lines, like line M and line N, are cut by transversal T, such that the alternate exterior angles are congruent. Again, they're called alternate exterior. They're alternate because they're on opposite sides of the transversal, and they are exterior because they're on the outside of the parallel lines. If those alternate exterior angles are congruent, then those lines, M and N, are parallel. So we can put our little parallel lines there. That's the alternate exterior angles converse. Now here's our alternate interior angles converse. Very similar to the last two. If two lines, like line M and line N, are cut by a transversal, line T, such that the alternate interior angles are congruent, then those lines are parallel. M is then parallel to N. So we can put our little congruent marks. I mean, not congruent marks, parallel marks. The arrows mean they're parallel. Okay, so far we've said if the lines are cut by a transversal such that the corresponding angles are congruent, the alternate exterior angles are congruent, the alternate interior angles are congruent. If one of those three things are true, then we know the lines are parallel. We have one more to talk about. This is our last one. It's slightly different. It's the same side interior angles converse. It says, if two lines, like line M and line N, are cut by a transversal, T, such that the same side interior angles are supplementary. Again, they're called same side because they're on the same side of the transversal T, and they are interior in between the parallel lines. If these guys are supplementary, meaning they add to 180 degrees, then those lines are parallel. So we can put our parallel markings, those arrows. Okay, those are all of your converse theorems. Those are the 4 ways to prove that lines are parallel. I think it is high time to do some examples. Alright, our first example, we're going to find the value of x that makes these two lines parallel. So we're given some angle measures. This guy is 2x plus 1 degrees. This guy is 3x minus 5 degrees. If we want those lines to be parallel, what needs to happen with those two angle measures? Well, what position are those angle measures in? I see they're inside the parallel lines, so they're interior. And they're on opposite sides of the transversal, so they must be alternate interior angles. And for lines to be parallel, those alternate interior angles must be congruent. Woo, big arc. Woo, big arc. And congruent means they have the same measure. So, write down what we said. Alternate interior angles must be congruent for those lines to be parallel. So let's set them equal to each other and solve for x. 2x plus 1 equals 3x minus 5. I'm saying let's subtract 2x on both sides, and we'll get 1 equals x minus 5. Let's add, whoops, I got excited. Let's add 5 to both sides, and we'll get x equals 6. And just for funsies, let's plug it back in and see what we get. 2 times 6 plus 1 is 12 plus 1 is 13 degrees, and 3 times 6 minus 5 is 18 minus 5 is 13 degrees. That was what was supposed to happen, that those angle measures were congruent, equal to each other. And since those alternate interior angles are congruent, then those lines are parallel. Oh, so very nice. You know, let's do another one. Okay, here's our next example. This is a drawing. You might not notice it or recognize it right off the bat, but this is a drawing of a windshield. And these are your wiper blades. And you measure the angle of inclination of both of your windshield wipers, because you're into that sort of thing, measuring measures of inclination, and you find that they are both 30 degrees. And you think to yourself, are these windshield wipers parallel? Well, what angles did we just measure? We measured some corresponding angles. Ah, we see those corresponding angles are indeed congruent. Those corresponding angles are congruent. And we know that if the corresponding angles are congruent, then the lines, in this case the wipers, are parallel. So yes, the corresponding angles are congruent. Que fabuloso. Très bien. You know, let's do another one. Here's our next example. We've got line M and line N and transversal T. We've got some angles that are marked congruent. And the question is line M parallel to line N? Why or why not? Well, I see we have some angles that are marked congruent. What kind of angles are those angles? I see they're outside the parallel lines, so they must be exterior angles. And we see they're on opposite sides of the transversal, so they must be alternate exterior angles. And we know that if alternate exterior angles are congruent, then indeed the lines are parallel. Yes, the alternate exteriors with an E angles are congruent. Wonderful, wonderful, darling. I think we've got it in us to do one more example. All right, here's our last example. We've got these two lines, line A and line B. And then we got this triangle going on between it. And the question is line A parallel to line B? Why or why not? Well, there's a couple ways we could look at this. We could use, let's see, this line. I can extend it. We could use that as our transversal. So we could totally ignore the other one and just look at, is that working for you? Yes. Totally ignore that other one and just look at those two. And if we knew what x was, then we would know the measures of the alternate interior angles. And if we knew that those measures were equal to each other, then we know the alternate interior angles were equal to each other and congruent. And if we knew the alternate interior angles were congruent, then we would know the lines are parallel. So let's see if we can figure that out. To figure that out, let's look just at these angles up here at the top. So we have a 60-degree angle here, a 60-degree angle right next to it that's adjacent, and this angle x. All together, those three angles make the straight line A. And a straight line is 180 degrees, so we could say that x plus 60 plus 60 equals 180 degrees. So that means x plus 120 equals 180 degrees. Ooh, which means x equals 60 degrees. So now going back to our plan here, we see that the alternate interior angles are indeed congruent, thus the lines are parallel. Yes, the alternate interior angles are congruent, so A is parallel to B. Now we could have done this a different way, without even solving for x. We could have seen this angle 60 and this giant angle here that encompasses both the 60-degree angles up at the top. That guy is 60 plus 60, which is 120 degrees. And we could have said, well, since 60 plus 120 equals 180, and these are alternate, no, they're not alternate, they are same side interior angles. This angle 60 and this whole angle here are same side interior angles. Those are supplementary, so yes, those lines are parallel. Also, The same side interior angles are supplementary, so line A is parallel to line B. Great job, scholars! Those are all of our converse theorems. You did wonderful. I think you deserve a reward. Guys, this is Bean. This is my doggo Bean. She loved our last episode. Oh yeah. It was so soothing, she slept all the way through it. All right, love you, scholars. Keep on that hustle. You're doing great. I appreciate you. I'll see you next time.